So in this problem, we're going to do our KCL, KVL example. So I've already drawn the circuit out here a little bit. Again, did it by hand real fast. 50 volt DC power supply over here. 2 amp current supply over here. 1 ohm, 5 ohm, 4 ohm, 10 ohm. So we're going to do, first off, we're going to look at what we're going to do here just from a conceptual phase. So the first thing that we're going to do, actually I'm going to do this in red. Our 2 individual loops. So the first loop we've got is going clockwise again. We make it in clockwise just for ease sake. So we're going to do one clockwise, and again we're going to do another clockwise. So these are our 2 loops that we're going to use to solve for this system. So the other thing that's important to note that's not on here right now is our positives and negatives. So this is going to be a positive to a negative. So that means it's a normal resistor, power is coming out of the system. Here we've got another positive to negative, a normal resistor, power coming out of the system. And here we've got positive to negative, power coming out of the system. And here we got here to here, so if we're going around this loop. And then we also have, I think that's it actually. So this is also going to be V1 up here. This one is going to be V2 over this point. So V1 is like from here, just that dot there to that dot. So go up and imagine a V1. This one's a V2 over this resistor. We've got a V3 over this resistor you can picture, and we've got a V4 over this resistor, right from here to here. Okay, and 2 amps supply, it looks good. So what we're trying to do, solve for this, is it says determine all currents and voltages. So first thing we're going to do is get all of our equations that we can get out and see what we can solve. So the way I approach this one first is Kirchhoff's voltage law, because I think that's slightly easier sometimes. And sometimes that'll give you the answer depending on how the circuit is set up right away between 2 of them. So this is our KVL1, this is our second KVL. So for our first KVL, we're going to do the equation. So we're going to start here and work our way around. So KVL1, and that, good, we can still see everything, yes. So this is going to equal, we're going to go pass through this 50. So we're going to go minus 50, and then we're going to go through this one. So that's going to be, what is that? Plus V1, because it went from positive to minus. And then we're going to go through V2 again. So that's going to be plus V2. We're going to go down through here, and this is going to be plus V3. And we're going to go back, and that's going to equal 0, because we went to one whole loop. So minus 50, so how do we get the next bit of numbers? So the next bit of numbers that we get for V1, V2, V3, remember V equals IR. I'm going to put that, where am I going to put that? So we can see it. We're just going to put it right underneath. Well, we'll remember it. V equals IR for each of these. So V equals IR there. Just remember, we're going to box that. Don't want it to mess it up. So now we're going to do minus 50 again for this one, because that's where we started. And then V1 is going to equal to what? IR, which is going to be what? I1. So this is going to be I1. I1. So plus I1 R1. So that's going to be I1, which we don't know, and then R1 is going to be 1 ohm. And then that's for the V1. So now we're going to go for V2. So we're going to go down here to V2. We're going over here, and this current one we're going to write as I2. So I2 coming down, we're going to do I2 times, what is this? V equals IR, so I2 times 5. And then we're going to go to V3, and what does V3 equal? V3 equals, we're going to call this one again, so I1 is coming in here, and we know that anything that happens in front of it is still an I1. So this is actually an I1 coming in here. I1. So we're going to have, for that one, I1 times, what is this, 4 ohms. That's going to equal 0. Okay, so that's our first equation. Let's see, and this is going to be I1. We're going to simplify this out a little more, so it's going to be minus 50 equals I'm going to pull this to the opposite side. So remember, opposite, positive, and then each one of these are going to be equal to I1 times 1 plus I1, 4. So it's going to be I1 times 5 from those two. Plus we have 5I2, I2 times 5. And that's it for that one. So we're going to box this one and save it for a minute. That's what we got. 50 equals 5I1 plus 5I2. So what's our next one? So we just did our loop, our first loop over here. So now we're going to do our next loop. And we're going to do that as KVL2. And KVL2, we're going to go around starting, well, it doesn't matter where we start. We can pick any single spot along the way. So what we're going to do for this one, I am going to start right here at the 5, at the V2 where the I2 happens. So we're going to go this way. So remember, we're going now against this. So this is a minus and a plus. So this is going to do what? It's going to switch the sign on us. So we're going to have minus 5I2 because it's 5 from that. I2 because it's I2 going. Minus because we're going in the opposite direction. Plus, now we're going to go around here into this loop. What do we got here? We have a current source. So what is the voltage of a current source? Well, we don't know that right now. So we're just going to call that VC, the voltage of the current source. And then we're going to come down over here. And again, we've got negative first and then a positive. So what's that going to mean? That means we're going to have a negative here. And then we're going to have V4. 4. And that's going to equal 0 because we went back to the same spot. So we have to sub in for V4 now. So it's going to be minus 5I2 plus VC minus, what is V4? We're going to have to look, what can we get with V4? Well, we've got IR, so that's going to be 10 ohms. And what is our IR? Because remember, V equals IR, just like we did over here. Well, we actually have our current. Makes it really easy. It's 2. So we're going to have 5 ohms times 2 amps. And that 2, again, comes from that current source because it's going right around. And that's going to equal 0. So this is our second equation. I'm going to box that right up and nice. And so finally, what do we need again for the next bit? We have, right now, we have 1 unknown, we have 2 unknowns, and we have 3 unknowns. So 3 unknowns means we need 3 separate equations to be able to solve them. So where do we get our third equation from? We get our third equation from Kirchhoff's current law. So we're going to do this one up here. Kirchhoff's current law. And Kirchhoff's current law says we're going to take a node, let's just call it that one, okay? And what's coming in has to equal what's coming out. So in equals out. So coming into the node, what do we got? We've got this I1. What else do we've got coming into this node? We've got a 2 amp source coming up here, because remember that's going to follow the whole way up. So it's going to be plus 2 equals, and then our coming out is I2. And that's going to be our third equation. So we're going to box that one. So I'm going to show you a super trick to be able to solve these really, really fast. So we can plug this into here and solve for this, and then plug that into here and solve around to be able to get all of these. Or we can do matrix equations. And I'm going to teach you the really fast way to do matrix equations with your calculator. So what we're going to do here is we're going to have to rewrite these 3 to get them in the correct form. So for our matrix equation, we're going to do, just so we kind of know, this is, actually, let's do this in red. Let's do this part in red. I1, I2, what's our third variable? VC, VC, and then we're going to put answers over here, or just constants, whatever you want to call that. Let's just put that as number here, constants. So for our equation, we're going to have, and remember, we're going to kind of put a little line off there to the side. But I1, so let's go to this first equation here. We're going to have 5 I1 plus 5 I2 plus, I don't see any VCs in there, so this is going to be 0 VC equals positive 50. Then we're going to go to the next equation down here. We're going to go, how many I1s? I don't see any I1s, so we're going to go 0 I1s. How many I2s? We've got minus 5 I2. And then we've got how many VCs? We've got 1 VC. And then what's the number that's coming out of this? We've got what? What's our number? 20 coming out of that? 10, 20, let's look. We've got 5, 50, 20 coming out. And again, how did we get 20? Let's just go back real fast. We've got, for this one, for this equation, we've got 5 I2 plus, so that's going to be 5, that's 10 there. Where is our 20 coming from? Let's look real fast and see if we can grab that. 20 equals 10 times 2 amps. Why did we get 5? So let's look back here again. KVL2, this is the second loop. So we're going around here because remember we had 5 I2, which is this one. We had our VC, which is this one. And so this is not a 5, this is a 10. I apologize, guys. That's my fault. So that's how we got 20 up there. So do you understand what happened there? I wrote the wrong one down. So if you look, we've got 5 I2 because we went this way. It's negative because we went the wrong direction, with the direction against, so negative to positive. We went up here to the 2. We don't know the VC on this, so that's why we have just a VC here. And then we came back here and we went again from negative to positive on this one. 10 times 2 equals 0. So that's right. Apologize. All right. And so we have that up there in this one. And then our third equation, which is this really simple one, we've got 1 I1. We've got minus 1 I2. We've got 0 VC. And we've got minus 2 as the number. So there's a really cool method of doing this by hand called Gaussian elimination. I'm going to post a link to that if you want to learn it. For now, we're going to go and do the calculator method. So these are 2 separate matrices, right? And we know if we're trying to solve this, let's just call this first one. That's actually, I'm going to make this into 2 separate matrices by doing this. And then another one like this. So matrix A and matrix B. I'm just going to call that A up here. You're going to know that refers to this one, and B over here. So remember, if we're trying to find the answers of these, solving the simultaneous equations, we do A to the inverse times B equals solution set. So how do we do that? Let's go on to the calculator. So calculator down. Let's see if we can see this. Yeah. All right. So first thing we're going to do, second math. That's going to pull up our matrices. We're going to go to the matrix A. We're going to edit it. It's going to be a 3 by 3 matrix. And you see I already plugged the numbers in here. Actually, let's go down so you can see that. Yeah. 5, 5, 0. 0 minus 5, 1. 1 minus 1, 0. Okay? So once you type all these individual numbers in, we're going to second quit. And now we're going to do it for the second one. So we can go second matrix. We're going to go to B. Actually, we're going to go edit and then B. And we're going to type in our 50, 20, minus 2 going down the list. Cool? And then finally, we're going to do our second matrix A up minus 1. Oops. Excuse me. So we're not going to do that way. We're going to do second matrix A inverse. And we're going to type that in. And then we're going to do times second matrix B. Boom. And that's our answer. So we're going to grab that. That's 4. The solution set equals 4, 6, 50. So what does that mean? Remember, we have to go back to this again. So 4 equals I1. 6 equals I2, 50 equals VC. And that's how we solve that kind of problem.